This is complex circuit number 2, and it has a little wrinkle in it, and that is that you are given the internal resistance. Whenever we write a symbol for the internal resistance, we usually chop off the corner of our circuit diagram, the corner nearest the power supply, and make our little resistor symbol, the zigzag line. And we're told that this is 0.5 ohms, if we ignore the sig digs for a minute. Here's my positive, here's my negative. And now let's fill in the diagram, the schematic, the circuit diagram, with the information given to us in the chart. We are told that the power supply has 45 volts. So if you were to connect a voltmeter in parallel across just the power supply, it would read 45 volts. Next, we're told that the internal resistance is 0.5 ohms. I've already designated that. R1, we're told, has a current of 8 amps. So whether we put the ammeter here or put an ammeter there, we know that this is 8 amps. Doesn't matter. The current is going to be the same all the way through that branch. It doesn't slow down. It doesn't diminish or get larger in quantity. It just uses up its energy. And we're also told that R2 is 2 amps, and this is R2 up here. So if we put an ammeter, say, right there, or we could put it afterwards as well, that's 2.0 amps. That takes care of that. Now, across R3, we have 10 volts. So if I were to put a voltmeter right here, across that branch, the R3 branch, it would register 10.0 volts. My R4 resistance, we're told, is 10 ohms. So that's 10 ohms of resistance. And R5 is 9 ohms of resistance. 9 ohms of resistance. So everything in my chart has now been transferred to the circuit diagram. Now we're ready to begin trying to fill in the chart. The first thing that you might notice is that at this junction right here, some of the current has to go there. The rest of the current has to go there. We're also told up here that this is 2 amps of current. So that when the 8 amps of current joins the 2 amps of current, we're going to have a total of 10 amps of current when the current combines at the very upper left part of my diagram. So if this is 2 amps right here, then this has got to be 2 amps right there. So we can say then that we have a total of 10 amps of current. Which, by the way, if we were to use Ohm's law right off the bat, if we have a total of 45 volts, and we've got a total of 10 amps of current, our total is going to be 4.5 ohms. Kind of the opposite order in which we solved the first complex circuit. We also now know that my internal resistance is going to have 10 amps going through it, because that's the total amount of circuit in the current. So we have 10 amps right there. And that means that we can apply Ohm's law right here. And if we have 10 amps and half an ohm, that 10 times a half means that 5 volts of my energy, 1/9 of my energy, is used up just getting out of the battery. So we're using up 5 volts across that internal resistance. That leaves me with 40 volts for the rest of the circuit. Now, if you follow this first branch, I'm going to switch colors. If you follow this branch right here, if we have 40 volts left, we used up 5 here of the original 45, so we have 40 volts coming into this first branch of R1. All 40 volts are going to be used up there, assuming no voltage is used up or no energy is used up going through the wire. So across R1, all 40 volts are going to be applied. And so that by the time the current gets back around to the starting point, the battery, it's plumb tuckered out. It has 0 volts. So we can use Ohm's law here again, V equals IR. We know we have 40 volts. We know the current is 8. So this resistance is going to be 5 ohms. Let's do that again. Now, we have 2 amps that are now on the way. And those 2 amps, some are going to go that way, some is going to go that way. Now, at this point, we recognize that R3 and R4 are 2 single resistors in parallel branches. And the voltage drop across parallel branches must be equal. So if you have 10 volts across R3, you've got to have 10 volts across R4. Those branches must have the same voltage drop. And if we apply Ohm's law down here, V equals IR, if you've got 10 volts and you have 10 ohms, then you can see that your current across R4 is 1 amp. If we stuck an ammeter in here, this would say 1 amp. Well, you recognize that we had 2 amps coming into the junction. If 1 amp goes to the right, then 1 amp has to go through the R3 resistor. So we have 1 amp here, we have 1 amp there, and that means if we use V equals IR again here, that means that R3 must be 10 ohms, just like R4 was. So now when we get back to here, let's change colors. At this point, we have 2 amps going through R2. And so at this point, the easiest way to find before we do R2, let's come back and look here. We have 2 amps going through my R5, which has a 9 ohm resistance. So that's going to be 18 volts that's used up across R5. 2 amps, 9 ohms, 18 volts. So now when we come up here, we can find the voltage, since we don't know the resistance and we only know the current. We can find the voltage by recognizing that if we started off with 45 volts, and as we come this way through R5, we're using up 18 volts. If we turn the corner here, doesn't matter whether we come this way or the other way, we're going to be using up 10 volts. And then when we get to the other side of R2, we have to be 0 volts on our way home. So now we have to figure out what is X so that we arrive back at the power supply or the batteries with 0 volts. And so 45 minus 18 minus 10. You can see 45 minus 10 is 35, minus 18, that gives me 17 volts right here. 17 volts across R2, and again using V equals IR, we therefore can say 17 divided by 2 is going to give me 8.5 ohms across R2. Now, if you wanted to double check this, you do know what the total resistance is already. And so you could use up, here's a half ohm, and here you would do your 1 over R, over here, 1 over R3 plus 1 over R4 would equal 1 over R equivalent, and replace these two resistors with one resistor. And then you could add this one, this equivalent, and this one, and put in one resistor. And then you would have, you could work backwards and confirm that this is 4.5 ohms.